Hello, my name is Henrik Arskog. I am a senior staff software developer with Visier, and today we're going to be talking about the Python connector. This video is part of a series of technical tutorials on doing foundational things with Visier. This video will help you understand how to get started using the Python connector. Specifically, we are going to be talking about the prerequisites that have to be done on the Visier site itself, as well as the steps involved in installing the connector, roughly the structure of a client application that uses the connector, as well as the various ways that we can provide credentials to the application in a secure way. We will wrap it up by talking about some of the specifics in order to use the connector in a Jupyter Notebook. In terms of prerequisites on the Visier side, the only objective we have is to make sure that the user that we have is assigned the appropriate capabilities. We will be using a demo user like this that has been assigned a demo profile. For the purposes of executing the demo, this user has been given super admin level permissions, which is okay in a test and development system for a user like this, but of course not in production. Looking at the profile then, the demo API profile, the access level has to be at least read-only. We're not writing any data in this demo, but it has to be at the API view level. In terms of capabilities, we have to make sure that this principal or this profile has API access, here called legacy API restricted. Okay, now we are in Visual Studio Code and it's time to start writing some Python. We're going to be running this tutorial inside a virtual environment to make sure that our dependencies do not bleed outside the scope of this demo. So, first of all, we're going to see that we are using a relatively recent version of Python. It doesn't have to be 3.11. We support 3.8 and newer. And we're going to be creating a virtual environment that in this demo we're going to call env. It does not have to be called env. This is just doing in this demo. Once we have the environment created, of course, we have to activate it. Now that we have the environment activated, we can install our dependencies, which for this demo is actually only the Visier connector. We will disregard that the pip needs an upgrade, but that is all there is to it, installing the Visier connector within a virtual environment. As for the application itself, we're going to start very, very small. This is, however, the essence of an application that uses the Visier connector. We import a session object, a constructor function that creates an auth object, as well as the appropriate API clients that we need for the application. In this case, we will start by creating the auth object. The auth object doesn't take any arguments in this case, because without any arguments, it's simply going to assume that everything is defined as environment variables. Once the auth object has been created, it will instantiate a session context with those auth parameters provided. Once we have a session, we can create the appropriate client and then make the API calls. In this case, we're simply calling the getMembers API for the gender dimension on the employee object. Presuming that it was successful, we will simply print out that response. While the code displayed is valid, the application itself will not run because the environment variables that make auth requires have not been given values in this shell session. So if we try to run it, it will complain that it lacks the values that it needs in order to log on. So we're going to fix that by creating an environment variable file. You can call it whatever you want. I'm calling it nzsh to indicate that this is an environment variable file that is specific for the ZSH shell. I can show this file, no problem, because it is a file that only sets the non-sensitive values in the file itself, and it prompts for things that are more sensitive. So now that we have this file, we can go ahead and source it, provide the API key, as well as the password for this demo user. Now that we have done this, we should be able to run this application problem. And success, it calls the API, get members, and returns the JSON representation of the various gender members on that dimension. What if the API call fails? There are two different ways to handle errors using this connector. If we deliberately choose an invalid dimension name, we can have the default behavior, which is that the API will return none, and we have to go and ask the client object for the last error. So running this, it will return a message among some other information that it cannot resolve the dimension gender X on the qualifying path employee, which is correct. Gender X does not exist. However, for developers that prefer a more exception-based approach, it is possible to tell the client to raise instead when an error occurs. We change the code then to simply say raise on error. And then, of course, there's no point in having the check on the members object itself. And in that case, we're actually going to get an exception raised, but the error message, of course, is the same, that it is unable to resolve the dimension gender X. Now we're going to make this example a little more advanced in the sense that we're going to be adding calls to query APIs as well. Currently, we only do model calls to the model API client, but we're going to add the query API client as well. The thing is that we can have multiple query API clients, that is no problem, but in order to simplify the example, we're going to be removing the old call, and now instead of the model API client, we're going to instantiate the query API one, and this is how you make the call. You instantiate the client. On the client you call, in this case, we're choosing to call a SQL-like because it renders a little nicer on the screen, which is the SQL-like format for defining queries against the Visier platform. And what we're doing here is simply counting the number of employees grouped by the genders with a time period that is 3 months long that started in 2022. All we're doing here is printing it out, but in principle, you could process that result in any which way that fits your needs. And we can see here that it does run, and it returns an array of field values that correspond to the type. Let's take a look at how we can control some of the behavior of these query APIs. Let's say that I do not particularly care for this way of displaying dates. So what I can do is I can provide options to the API in order to control how these things are being rendered. So let's do that. We'll create an options object, and we'll give it a single member in this case called member display mode, given the value of display. And then all we have to do is pass this options in. And now with that simple change, we should have a representation of dates that is more to our liking. And we can see here what it does now is that it shows us the last day of that previous period. If we change our date dimension to have, instead of having one member, it has, for example, 4 to cover a full calendar year, we can now run this. And now it will render 4 different date members, with each date member being the last day of the period that it represents. Now we're going to move away from operating system specific environment variables and create agnostic environment files called .envs. And we can start by creating a .env file that actually defines the environment from the operating system environment. So what we do is to just take the environment that we have. And we'll write that into a file that we call .env. This name matters. And show the contents of that file because it contains API keys and passwords, what have you. But now it's there and ready to be used. How we're using it, this is done using the .env library. So from .env, we're going to be importing a function, .env values. We'll be calling this function to read the values in this file, and we're going to be passing them in to this make auth function that will now create an authorization object from the values read from this file. To confirm what we have actually works, we have to test this from a session that doesn't have the environment variable set. Instead of simply setting those values to empty, we're just going to be creating a new shell version where we have a clean environment in terms of Visier environment variables. These ones are now not set, and when we run this, it will then consequently use the .env library to load this particular file and run the application. So here we say, despite not having anything set on the environment variable, instead the environment was set using the .env file, we were able to run this application. And as we shall see in the next session when we talk about Jupyter Notebooks, this distinction is quite important. In the last part of this video, we're going to be talking about the specifics around Jupyter Notebooks. There's not much, but the one thing that we have to overcome is the fact that the Visier connector is published on PyPy, and PyPy packages are not available through default channels when installing dependencies in Jupyter. So what we have to do, this is an SSH session to the Jupyter server, is you have to create a specific environment from which you then build a kernel that have the necessary dependencies. And there's plenty of documentation for how to do this online, but one thing to be mindful of is we have to first install Conda's version of pip, and then when we install the Visier connector, it will be installed as a dependency. So let's take a look at the packages that we have installed. First of all, we can see which environments we have. You can see that I'm already in Conda environment Visier API, but let's take a look anyway. We only have two, and the Visier API is currently active. So when I get a list, you can see that we have a pip version from the Conda Forge, and the Visier connector is the one installed from PyPy, what is currently the most recent version. We are now in Jupyter Labs, and this is a sample notebook that is effectively identical to what we ran inside Visual Studio Code, with the exception of instead of doing a print, we're importing the pandas library and we're loading our result set into a pandas data frame, and we'll write that out. The couple of things that we need to pay attention to first before we run this is that this here is run inside a Jupyter kernel that is based on the environment we just saw, the one that has the Visier connector installed to it as a dependency. The other piece is essential, and that is that the environment file has been placed inside this directory as well. Hidden files do require some additional configuration on the Jupyter side to be allowed, but if it's not your local machine, this is something that the administrator might be able to help with, because working directly with hidden files without this setting is difficult, if not impossible. So make sure that that has been set in the content manager, allow hidden. Okay, so here we are. let's run this. This little sample script here, that is the one that we're used to with regards to the query, loads the .env environment, logs into Visier, runs the specified query, loads it into a pandas data frame, and simply prints that data frame out. And that concludes the demo. Thanks for watching. To see more technical videos, please check out the description in this video or visit visier.com to learn more.